Hey guys, it's Mr. Knockme here. I'm coming at you with a statistics video today. Going to help you guys construct a frequency distribution given some data, or data, however you want to call it. Over here we have 50 pieces of data here collected for internet subscribers spent on the internet during their most recent session. They want us to create a frequency distribution that has seven classes. This is going to be a key number for us to use here. Now, for us to do this, we have to divide up our classes evenly, right? And we need to figure out how many elements should we have in each class, right? What's the class width? That's the first thing you need to find. I'm going to write that out right here. First thing you need to find is the class width. And in order for us to do that, it's a very simple thing. All you really need to do is take the highest number, right, the maximum data entry, minus the minimum, and divide it by the number of classes you want. And in this case, we want 7. So the highest number, we're going to go through here and look for it, I believe is going to be 86. I don't see any other numbers that are bigger than 86 as I run through here. And our smallest number, I believe, is 7. Yeah? So we're going to do that real quick. To find our class width, we're going to go ahead and take 86 minus 7, divide that by 7. I'm going to go ahead and open up my calculator here to help me out to look for it. Let's see here, 86 minus 7. I should probably turn this on first. There we go. So we have here 86 minus 7, right? Gives us a number here, and we'll go ahead and divide that by 7. And we end up with 11.285. Let's go with 11.9. 11.29, right? Now that's kind of an awkward number for us to count our classes with. I don't really want to keep finding 11.29 from one class to the next. So when we're doing our frequency distributions, even if it's 0.1 or if it's 0.001, you got to remember, we always round this up. That way it ensures that we get our last data entry for our maximum value of 86. If you don't round up, some cases you're going to end up missing out on your largest value. Okay? So we're going to go ahead and round up. Our class width is going to be equal to 12. This is what we're going to use to find our class width. Okay? So looking at this right here, we're going to go ahead and set this up. This is our classes right here that we're going to have. And the classes start off with the smallest value that you have, which in this case is 7. And it's going to go up 12 times. So you're going to count this out. 7, 8, 9, 10, and so on and so forth, all the way up to the next one. That's going to take forever for you to get through all 7. It's kind of a pain that way. So instead, what you could do is take your class width, which is 12, and simply add it to 7. When you do that, though, that doesn't tell you the end of your class. It instead tells you the beginning of the next class. If I take 7 plus 12, which is 19, that gives me the beginning of the next class value. Now, when you do that, you can do that all the way through to your 7 classes. So 19 plus 12 is going to give me 31. And the next one after that will be 43, 55, 67, and 79. These are the beginnings of each of your classes for all 7 classes. What the beauty of this is, it actually tells you what the maximum value of each class is, because if the second class starts at 19, the previous class actually has to stop right before that, which is going to be 18. Same thing with the next one for class number 2. If the third class starts at 31, the second class must have ended at 30. Right? I'm going to fill this out for the rest of them. 42, 54, 66, 78, and you can use this trick one more time. You can actually add 12 to the large number, and it'll also give you the top class of the last one, 78 plus 12, which is going to give me 90. It's a really neat little trick here, and if you actually go in there and count the elements from 7 to 18, you'll actually count out exactly 12. And if you go to any one of these classes and count from the lowest to the largest, you'll end up with 12 elements. All right, now that's just setting up the classes. After that, there comes the hard part. You actually have to go through the data and count how many times a number shows up between the class boundaries there. Between the classes of 7 and 18. So that's going to be our frequency, usually denoted with a fancy F. So I'm going to go in here. Usually like to do this in a different color. So for 7 to 18, I'm going to go through here and count, basically. And I cross it out as I go along. So that's 1, 2, right? Keep on going here, looking for things that are 3, 4, less than 18. 18 or less, I mean. 5. Is it only 5? I think I'm missing. Oh, and one at the beginning here. 6 numbers. 6 numbers. I'm going to write that down. So the total numbers that are between 7 and 18 shows up 6 times, right? And you're supposed to go through this and do this for all of your classes. And I feel like that's going to be a very boring video of me counting this out. So I already have these numbers listed. I'm just going to go ahead and write them down for you. And you can double check along the way. So I have over here 19 through 30 is going to be a frequency of 10. The next one is 13, 8, 5, 6, and 2. And that's how you create your frequency distribution. You just go through and count how many of the numbers are between your classes all the way through. Now, once you have this figured out, you can actually calculate other things that you're going to be asked to do in your statistics class. Another thing that you might be asked to do is calculate your relative frequency, right? Your relative frequency is a very simple idea. You simply take your frequency and divide it by your total frequency, meaning how many numbers you had to begin with. In this case, we had a total sample size of 50. So our relative frequency would just be 6 divided by 50, right? Which is roughly, what is that? 12%? And 12%. And you're going to do that for every single point along the way if they ask you to find the relative frequency. Another thing that might be asked from you is to find the cumulative frequency. Cumulative frequency. And it's just like you think. Cumulative means to add it up along the way. So for the first class, your cumulative frequency would just be 6. For your second class, you would take the frequency of the second class and add it to the frequency of the first class. So you end up with 16. And you keep going along the way. The next one is 13 for class 3. And you add all of the frequencies before that one. So it'll be 13 plus 10 plus 6, which gives us a total cumulative frequency for this class of 29. And you simply work your way through all the way to the end. At the very end, you should end up with 50, since you're dealing with 50 numbers to begin with. I hope this was helpful for you, that you'll be able to construct your own frequency distribution for all the data that you will be collecting. And with that, I'm going to end my video right here.